Today we are going to discuss about how to create minimum cost spanning tree using Kruskals algorithm. First of all, we should know what is a graph, what is a spanning tree, what is minimum cost spanning tree, and how to create minimum cost spanning tree using Kruskals algorithm. First one, graph. A graph is collection of vertices and edges where each edge has a specific weight or cost. Then second one, spanning tree. A spanning tree is a subgraph that connects all the vertices of the original graph without forming any cycles. So it contains all vertices and subset of edges such that they may not form any cycle. So we can create many spanning trees in which we are going to have minimum cost spanning tree. Then what is minimum cost spanning tree? So minimum cost spanning tree is a spanning tree where the total sum of weights of all its edges is minimized. The minimum cost spanning tree must satisfy three distinct rules. They are: first one is all nodes covered. It should contain all nodes. So all vertices. Then no cycles. It may contain subset of edges where it should not form any cycle. It cannot contain any closed loop or circuit. So no cycle. Then third one, minimum total cost. The sum of all weights of edges used must be lowest possible out of all possible spanning trees. There is a possibility of creation of so many spanning trees, but our concentration is to find minimum cost spanning tree, that too using Kruskal's algorithm. Now we are going to find or create a spanning tree, minimum cost spanning tree using Kruskal's algorithm. For example, figure shows a graph where it contains seven vertices and many number of edges. Each and every edge is having some weight. So 1, 2, 3, 4, 5, 6, 7 are vertices, and 1 to 2 there is an edge having weight 28. 2 to 3 there is an edge having weight 16, etc. There are many edges having some weights, and using this we can create many spanning trees. But the minimum cost spanning tree is also shown in here it is a minimum cost spanning tree. So we are going to create the minimum cost spanning tree from the original graph using Kruskal's algorithm. Now let me explain how to create minimum cost spanning tree using Kruskal's algorithm. Then Kruskal's algorithm is a greedy algorithm used to find minimum cost spanning tree for a connected weighted graph. See here, this is a graph where it is connected, means all nodes are connected with edges having some weights. There are seven vertices and many edges. Every edge is having some weight. There are no isolated vertices. Then its primary goal is to find subset of edges that connect all vertices at the minimum possible total weight without creating any cycle. Now, Kruskals algorithm, the steps. Step by step process is said to be algorithm. So first step, let G is a connected weighted graph having n vertices and weighted edges. It is a graph having 7 vertices and some number of weighted edges. The second one, initialize minimum cost spanning tree. We are going to create a minimum cost spanning tree. Before adding any node or edge, we will have an empty minimum cost spanning tree. So the cost of minimum cost spanning tree is 0 initially. Then arrange all edges of graph G in the increasing order of their weights. See, there are so many edges first one, second one, third one, fourth one, fifth, sixth, seventh, eighth, ninth. There are 9 edges. Each edge is having some weight. We are arranging these edges in ascending order of their weights. The costs are, there are so many costs. Say initially the smallest cost is 10, next smallest is 12, next smallest is 14, etc. So the weights are arranged in ascending order, right? Ascending order of their weights. So 1 6, 1 6 is 10, 3 4 12, 3 4 12, 2 7 14, 2 3 2 3 16, then 4 7 18, etc. So like this we have arranged all the edges in ascending order of their weights. Then select an edge with minimum weight. So the minimum weight out of these weights is 10. Select the edge 1 6. Select the edge 1 6 and select the edge from uh, select the minimum cost edge and add the edge to minimum cost spanning tree. Suppose 1 6 is the edge we have selected, add it to the minimum cost spanning tree, the weight is 10. This is the first edge we have added to the minimum cost spanning tree. Assume that we are going to create minimum cost spanning tree. There should be all the 7 vertices and we are going to add edges. We are going to add edges which does not form any cycles. Then select the next edge from the graph with minimum weight. The next smallest is 12. So select 3 4, 3 4, 3 4. So add 3 4 to the graph minimum cost spanning tree. 3 4 weight is 12. Adding this edge does not form any cycle. Then again repeat step 5 and 6 until minimum cost spanning tree contains n minus 1 edges, where n is number of vertices of the graph. There are 7 vertices and you may have 6 edges. Then repeat 5 and 6. 5, select next edge. Next edge is 14, 2 7 with 14, 2 7 with 14. So if you add 2 7 with weight 14, it is not forming any cycle. So you can add it. You can add it. Then repeat the same process. Select next edge 2 3 with weight 16, 2 3. Next smallest is 2 3. So 2 3. Adding 2 3 edge 2 3, not forming any cycle. 2 3 weight is 16. The next one is 4 7, edge 4 7 with weight 18, 4 7, 4 7. If you add this, it forms a cycle. So you are not going to add it, you are going to discard it, right? So the edge, the next edge, if it is forming any cycle, do not add that one. Just discard it and go to having the next edge. The next edge is 4 5. 4 5 with 22. If we add 4 5, it is not forming any cycle. The weight is 22. You can add it. Then next edge is 5 7. 5 7. If you add 5 7, it is forming a cycle. So you discard it. So don't add that. Repeat. Again, select next edge 5 6, 5 6 with 25. Adding 5 6, not forming any cycle. So you may add this to the minimum cost spanning tree. Then 1 2. 1 2, adding 1 2, forming cycle. So you don't add this edge. Now there are no edges, right, to add. Now see 1 6 6 5 5 4 4 3 3 2 2 7, forming a spanning tree minimum, that too as we have added only smallest edges, it is said to be minimum cost spanning tree. The total weights are 1 6 is 10, then 6 5 25, then 5 4 22, 3 4 12, 3 2 16, 2 7 14. Add this There are 1, 2, 3, 4, 5, 6, 6 edges. 1, 2, 3, 4, 5, 6 edges. Add them. 5 to 7, 7 to 9, 9, 6, 15, 15, 4, 19. 1, 2, 3, 4, 6, 8, 9, 99. The total weight of the spanning tree is 99. So in this way, we have created a minimum cost spanning tree with the least possible weight edges. So this is said to be a minimum cost spanning tree. For clarity, it is specified in here 1, 6, 6, 5, 5, 4, 4, 3, 3, 2 and 2, 7. This is the minimum cost spanning tree. So this is created with the help of the algorithm called Kruskals algorithm, where initially we